Hello everyone. In this lecture, we are going to cover maxima and minima part. If there is a function, then how to find out maxima and minima value of that function. Okay, this lecture is going to be very short. Okay, so let's say there is a function y equal to fx. I want to find out maxima and minima part of this function. So let me draw a curve first. Let's say this is x and this is y equal to fx. Let's say this function is varying like this. Okay, I'm assuming this is function varying like this. Okay, so here in this graph, it's clearly visible that value of maxima of this function is at this point. Okay, so this value is maxima. Okay, so here y max and this point is y min. So at this point, what is value of x? Let's say this is x1. So x1 value of y is maxima. At this point, value of x is, let's say, x2. So at x2 value of function is minima, and at x1 value of function is maxima. So I am getting here x1 and x2 correspondingly. I am getting maxima and minima. So how will I find out of a function minima or maxima? Okay. So here one thing is very clear. Wherever is maxima or minima, there is differentiation zero. Differentiation means slope zero. Here if I'm seeing dy upon dx, so this will be zero because this is just changing nature. So here if I draw one tangent, slope of that tangent will be zero. That means here slope will be 0. Here also slope will be 0. Here also if I am calculating dy upon dx, this will be also 0. So wherever function value will be maxima or minima, at that point first derivative differentiation will be always 0. Okay, first derivative will be always 0. Now if I want to find out maxima, so this is maxima. So here dy upon dx is 0, but dy upon dx double differentiation means rate of change of slope, that is going to be negative, means dy upon dx decreasing here. So double differentiation of this will be negative. Maxima here double differentiation negative, here double differentiation positive, means rate of change of dy upon dx is going to increase here. Okay, so here in mathematical term, if there is a function y equal to fx, so for maxima and minima, we will always follow two steps. In step 1, always you find out dy upon dx, okay, slope of a function d by dx fx. Always you find out dy upon dx and put equal to 0, because here dy upon dx 0, dy upon dx 0. So wherever it will be maxima or minima, there will be differentiation of function will be 0. So you do this one and find out and find value of x. Okay, value of x you find out that at what x, like x equal to x1, x equal to x2, this value of function, derivative of this function is 0. So find value of x. Second step, so in second step I will take here two parts. First for maxima and second for minima. So if I want to find out maxima, then double differentiation d square y upon dx square, d square y upon dx square, this will be negative. Why I am saying negative? Because there is maxima. So here rate of change of dy upon dx is going to decrease. Here slope is negative. Here, so this is double differentiation is negative, then it will be maxima, and double differentiation is positive, so this will be maxima, sorry, minima. So this is case for maxima, this is case for minima. Okay, so what we have to do, always you find out dy upon dx, put 0, get the value of x. At what x we are getting dy upon dx? Condition 1. Then for maxima, double differentiation must be negative at that x. At that x means we are getting a value of let's say x1 and x2 you are getting. So at x1, dy upon d square y upon dx square is negative or positive. we will check. Negative or positive we will check. So negative, okay, let's say here in this graph at x1 I'm getting maxima. So d square y upon dx square at x1 will be negative. Here at x2 I'm getting maxima, so it will be positive. Okay, so this is how we can find out maxima and minima of any function. Okay, so let's take one question. Okay, I'm saying that if there is a function, let's take in general x minus 1, x minus 2 whole square. So find maxima or minima of function. Okay, maxima and minima of function. Okay, so maxima will be here. If I put infinitive, it will be infinitive. Okay, so maxima will be infinitive, minima will calculate. Okay, so here find minima of the function. So minima means we will find out here. We have to find out minima. So here I will expand this one. Expand means x minus 1. Let's expand this one. So it will be x square plus 4 minus x square plus 4 minus 2 into 2 4x. Now again you multiply. So x cube plus 4x minus 4x square minus x square minus 4 plus 4x. Okay, so we can write here y equal to now x cube, this will be minus 5 x square, this will be 4x 8 and 4x 8x minus 4. Okay, so this is we are getting y. So what we have to do, dy upon dx. So differentiate this one. 3x square minus 10x plus 8, this is equal to, we have to put 0. So when I am putting this equal to 0, then I will get here, let me find out, this is quadratic equation. So minus b plus minus under root b square minus 4 a c upon 2a. Okay, so this is x I'm getting. Okay, so let me calculate this value. X equal to positive 10 plus minus 100 minus 4 into 3 4 into 3, this will be 4 into 3 12 12 into 8 96. So this will be 100 minus 96 4. So this is upon 6. So I'm getting here 10 plus minus, this is 2 upon 6. So one time if I take positive, so it will be 12 upon 6. 12 upon 6, so it will be 2, or if I take negative, so 8 upon 6, it will be 4 upon 3. Okay, so these two value I'm getting here. So if I'm calculating double differentiation, okay, so double differentiation d square y upon dx square will be equal to of this one 6x minus 10. So d square y upon dx square at 4 by 3 will be, this is 6 into 4 by 3 minus 10, this will be 3 into 2, so 4 into 2 8 minus 10, this is negative. So this double differentiation at 4 by 3 is negative. That means function value is going to be maxima at 4 by, function value is going to be maxima at 4 by 3. Okay, so here d square y upon dx square, this at 2 will be differentiation 6 into, this is 2 minus 10, so this is going to be positive. So this value is going to be minima at this function. Okay, so here this value is minima, so here I can say this is positive. That means function will be minima will be minima at x equal to 2. Okay, so x equal to minus 2, this is no sorry, x equal to 4 by 3, it is going to be maxima. Okay, so that will be local maxima, because maxima will be infinity we put here, it will be very big number, infinity. So here I'm getting minima, so minimum value of, we have to find out minima. So y minima will be, we will put here 2, so 2 minus 1, this is 2 minus, this value will be 2 minus 2 square, so this value is going to be 0. Okay, so this is value of y. Okay, minima. Okay, what would be maximum value? We can find out here by putting this 4 by 3. Okay, okay. So this is how we can find out maximum minima. Let me take one more example. Okay, so this part is over. So let me take one more example. So this is, if I'm saying that there is a function, let's say x square minus 4x plus, let's say, so y equal to find maximum and minimum. So find maxima or minimum, whatever is possible. So this is dy. What will do? Dy upon dx. So this will be dy upon dx will be equal to 2x minus 4, put 0. So I'll get here x equal to 4 upon 2, this is 2. So x equal to 2. Then find double differentiation. Double differentiation will be 2 only. So this is positive, positive, positive means function will be minimum. Minima at function will be minima at x equal to. Okay, so what will be minima? It will be minima. So minima will be 2 into 2 minus 4 into 2 plus 2. 4 minus 8 plus 2. This is minus 4 plus 2. This is minus 2. Okay, so this is how we can find out maximum and minima. What we have to do? Always you differentiate, put equal to 0, get the value of x. At that x you check whether double differentiation is positive or double differentiation is negative. If double differentiation positive, function will be minima. Double differentiation negative, then function will be maxima. This is all about. Okay, so this much part is maxima minima. So I want to solve a more question based on differentiation concept. Okay, because you will see that, okay, you will see that in differentiation question some more concept is required. Means when you will solve problem, then you will understand. So like question I'm taking based on differentiation. Like if I'm saying e to the power t square, then find differentiation with respect to t. So if there is other than t, then we have to differentiate it once again. So what is differentiation of e to the power? Simply, let's take here x. Okay, so d by dx x square. Okay, so here if there is anything e to the power, that will remain there. But if other than x is there, we have to differentiate once again. This is differentiation of x square is 2x. Okay, similarly we can take here sine. Let's take x square. So this will be sine x square differentiation. This is cos x square, but there is x square, so we will differentiate it once again. So it will be 2x cos x square. Okay, so this is how we can solve it. We can take one some more example. Like if I'm saying that e to the power, let's take here e to the power 2 into x cube d by dx. So what you have to do? Again, whatever is power, that will remain same, but here we have to differentiate once again. So this will be 2 into differentiation of x cube is 3x square. So this will be 6 into x square. So this is how we can differentiate. Next, if I am saying differentiate cos 2x, okay, so here it will be cos minus cos minus sine 2x, but there is other than x, we have to differentiate it once again. So here 2. So answer will be minus 2 sine 2x. Okay. We can take some more example, like let's take 5. Okay, question only. So here, if you have to find out d by dx, let's take ax plus b. So what you have to do here, you have to take, you assume for a moment this is power n. So assume for a moment this is x only. So it will be n into x to the power n minus 1. But this is not x, this is ax plus b. And if this is not x, then we have to differentiate it once again. So if you differentiate it, so ax plus b differentiation will be a. So answer will be a and ax plus b to the power n minus 1. Clear? So this is how you can differentiate. So let me take differentiation of, if I'm saying, let's take 1 upon root x minus 1 d by dx. So what you do? Again, this is x minus 1 to the power minus 1 d by dx. So assume for a moment this is x. So what is integration, differentiation? N into x to the power. This is, you take, assume for a moment x, so x to the power minus 1. So minus 1 into minus 1 minus 1 and into n to the power. So this is not x, this is x minus 1. But if there is anything other than x minus 1, once again we'll differentiate, it will be only 1. Differentiation of x is 1, differentiation of 1 is 0. So I'll get here minus 1 upon x minus 1 whole square. Okay, so this is how we can differentiate. So you solve question. Okay, all concept of differentiation is completed already. We have to practice more and more question so that your concept can be clear. Okay, so it's only dependent upon how many questions you are solving. Okay, so better you solve as much question possible of differentiation so that your concept could be clear. Okay, so this is all about differentiation and maxima and minima. Okay, thank you so much.